So I hope that you watched and understood my first video regarding the cellular respiration overview, because in this video I will be talking about glycolysis, which is the first step in this process. Now, glycolysis is a cellular process that takes place in the cytoplasm, and it is anaerobic, which means it does not require oxygen. Okay, anaerobic does not require oxygen. Glycolysis has two phases. The first phase is called the preparatory phase. So here I'm going to put number 1. This is the first phase of glycolysis. Now in this phase, this is glucose. So the glucose, we have 6 balls here, which means 6 carbons. This glucose goes through a reaction where an enzyme called hexokinase adds a phosphate onto the glucose to produce glucose 6-phosphate, which means that this phosphate now is on the 6th carbon of glucose. So this is the HK, or hexokinase. Anytime you see an enzyme that has the name kinase, that means that it phosphorylates a molecule. Now hexo means it has 6 carbons. Hexo is for 6. So hexokinase phosphorylates glucose by taking an ATP and taking one of its phosphates and putting it on glucose to make a glucose 6-phosphate. Now the next step, an isomerase comes and converts glucose 6-phosphate to fructose 6-phosphate. Now this is in the purpose of making the molecule symmetrical, and you'll see why that is. Now here we have another enzyme called phosphofructokinase. Okay, so it's another kinase. It's going to phosphorylate this molecule. See, as you can see here, it adds another phosphate to another carbon by breaking a phosphate off an ATP. Okay, so now this enzyme makes fructose 1,6-bisphosphate, okay, or diphosphate. Now this molecule, you can't see it here properly, but this molecule is symmetrical. Now we've created symmetry, and in the 4th step, this symmetrical molecule is broken down to two molecules that carry 3 carbons each. Okay, this is the preparatory phase. We have phosphorylated, we used 2 ATPs, and we have made 2 molecules that are pseudosymmetrical. Now, what's going to happen here is that this molecule, is going to go through the energy conserving stage or the energy producing stage. Here, just to summarize, we're going to produce 4 ATPs and 2 NADHs. We talked about that earlier. This is the reduced form of the electron carrier NAD+. Now, in the first step of the energy conserving stage, we have 2 phosphates being added to each of these 2 molecules. So here everything has a 2 in front of it because this is happening to 2 molecules. Remember, we broke down the fructose 1,6-bisphosphate to 2 molecules. So we have a phosphate added to each molecule, and here we have a redox reaction. This molecule is being oxidized as the NAD plus is being reduced to NADH. So this is being reduced. So this is a reduction. This reaction is an oxidation. An oxidation always accompanies reduction. Now we've made 1,3-diphosphoglyceric acid. Now, if you're in grade 12, you probably do not have to memorize the name of all these molecules and substrates. It's unnecessary. And the next step, here we have, again, 2 because this is happening in parallel. 2 ADPs, so adenosine diphosphate. Don't forget that this is an A. Adenosine has 2 phosphates. It's not a very high energy molecule. 2 ADPs are picking up one of these phosphates from this molecule to make an ATP. So ADP plus, I'm going to write P here, to make an ATP. Now adenosine triphosphate. That's what the T stands for. Now, adenosine triphosphate is a high energy molecule. This bond here is very energetic. When this bond breaks, it releases a ton of energy that can be used to power so many cellular processes, and that's why this molecule is what the cell strives to make by this process. Now, in the next step, the phosphate is moved to a second position from like carbon 3 to carbon 2. And in the next step, a molecule of water is produced from each molecule. So again, the subscript or like the coefficient 2 means that it's happening in parallel. And then in the last step, we have 2 other ATPs being made. Again, this is an 2 ADPs, adenosine diphosphate, making 2 ATPs. Keep in mind here, please, that this method of ATP production is called substrate level phosphorylation. Substrate level phosphorylation. Whenever we use the word substrate, we're talking about enzymes, because the molecules the enzymes bind to are called substrates and they are converted to products. So substrate level phosphorylation talks about how an enzyme grabs a phosphate, grabs a phosphate from a molecule and adds it to ADP to make ATP. So this is catalyzed by an enzyme, made faster by an enzyme. ENZ for me is enzyme. Now, this reaction produces 2 pyruvates. So each pyruvate has 3 carbons, okay? And so we started with a glucose that has 6 carbons, and we broke down that glucose to 2 pyruvates that have 3 carbons each. So since some bonds were broken, we had our lowly NAD pluses that grabbed the electrons and held onto them for later on. So keep watching these videos to see what happens to the NADHs and why they are so useful. Okay? So I hope this video was helpful. Please subscribe to my channel and ask me for more videos that you'd like to see. Bye!